Okay, class, this is the second part of guided notes number 3 in Unit 2, talking about how to calculate the relative abundance or the average atomic mass. And what I want to stress to you is when we're talking about an average atomic mass, there's actually no averaging involved. There's no division involved to calculate this because the percentages are all going to be responsible for a different weight. It's like if you calculate your grade point average, essentially. Each of your semesters counts a different percentage. So you can't just add the three numbers together and divide by 3 because they don't all count the same. Well, that's the same for a relative abundance or an average atomic mass. So the way that you will solve these problems is you will actually do the steps that are involved. You're going to multiply the mass of each of the isotopes by the percent abundance. So when you put that into the calculator, what you need to make sure is that when you put these percentages in, that they are actually percentages on the calculator. So you use the percent key. So to type that in, you would actually put in 95 decimal 52, and then hit the second and the open parentheses button, and that's the percent button. Then you can multiply that by the actual mass here, which is given us in mass number format of 12. So 95.52% times 12 is going to give you 11.4624, and our unit here is going to be called an atomic mass unit. So an AMU, atomic mass unit. So again, what I did was take that mass of 12, multiply it by my percentage, and that gives me a value there. Once I've done that for each step, I'm going to then add those values together. So the next thing for me to do is take 13 and multiply it by 3.16%. When you do that math and work that out, you get 0.4108. I'm just going to go ahead and write all the decimals here, and then we will take and round that up a little bit at the very end. And then the last step is 14 times 1.32%. When you multiply that out, you should get 0.1848 atomic mass units. So that's really the first step. We've taken each mass and we've multiplied it by the percent abundance. Now to calculate the average atomic mass, all we have to do is add these three numbers together. So we're going to add these three numbers together, and that's going to tell us our average atomic mass for this particular set of isotopes, which is 12.058 atomic mass units. Okay, so our final answer, again, does not involve any division whatsoever. We simply have to do these two steps: multiply mass times percent and add that all together, because this is a weighted average. And what you should notice when you calculate a weighted average is that when you calculate this average atomic mass, this really should be a value that is very close to the mass of the highest percentage. Okay. And that should really make sense. 95.52% of all these isotopes weighed 12 atomic mass units. And our average was just a little bit over 12 because we had a few that weighed 13 and a few that weighed 14. So that dragged it up just a little bit. But for the most part, everything was there right on at our 12 for average atomic mass. So again, in this case, all you really have to do is you have to do a little bit more work to read through the question and write down what you're reading. So what is it telling me? 93.41% of lithium has a mass of 6.341 atomic mass units. And the next one, 3.65% has a mass of 6.25 atomic mass units. 1.87% has a mass of 6.823 atomic mass units, and 1.07% has a mass of 6.589 atomic mass units. So as I'm reading that question, I'm writing what I'm reading down. And then I think about my steps. I have to take these percentages that I'm given, multiply them by the masses that I'm given, and get a value for each one. So I'm going to do math in those 4 steps, multiplying those percents times the mass to get values for the actual atomic mass units. So I should get 5.923 atomic mass units here. I get 0.228 atomic mass units here, 0.1276 atomic mass units, and 0.0705 atomic mass units. So I've done step one. I've multiplied the percentages by their atomic masses. To get the final answer, I'm going to take all of these values and I'm going to add them together and I'm going to get a total. And when I get my total, it's 6.349 atomic mass units. And when I examine that, again, what is my highest percentage? Well, my highest percentage was at 6.341. So it should make sense to me that my mass should be very close to that 6.341. You're actually going to do a lab that deals with this topic. It's called the Beanium Lab, either today or tomorrow, to practice that information. So just remember, average atomic masses, there's no division involved. That's the number one thing that students mess up. They just will take all this stuff, add it together, and divide by a number. That's not how you do an average weighted atomic mass.